In number 51, we are asked to find the volume of a cone with a height of 9 meters and a base radius of 8 meters. So in a cone, it looks something like this. So radius of 8 and a height that's perpendicular to that base of 9. And our final volume is going to be measured in meters cubed. So the formula for volume of a cone is 1/3 times the area of the base times the height. And keep in mind that this base is a circle. So the area of the base is pi r squared, and then we will multiply it by our height. Now, it doesn't say if we should leave our answer in exact form or if we should round it to the nearest tenth, so we're going to go for exact. So when you write it in exact form, you leave it in terms of pi. So let's plug in our numbers. We have 1/3 times pi times 8 squared times 9. I'm going to leave that 1/3 in there for a second and do 8 squared, which is 64 times 9, and we get 576. So if I simplify this, I can write as 576 pi all over 3. So take and divide 576 by 3, and we end up with 192 pi meters cubed. Final answer. Okay, so we're switching gears from area and volume to talk about the distance formula, slope, midpoint, equations of lines. Number 52, we're asked to find the distance between these 2 points. So let's label the first point with x1, y1, just because it's listed first. And the other point is x2, y2. So finding the distance formula says we'll take the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So you have d equals the square root of 5 minus 3, quantity squared, plus 5 minus a negative 1, quantity squared. Okay, with 5 minus 3 we get 2, and we'll square that. And the second set of parentheses, because we're subtracting a negative, we know that that turns into addition, so that gives us 6 squared. So d equals the square root of 4 plus 36. So d is equal to the square root of 40. And we're going to leave this in exact form, but we do need to simplify it. So factor the 40 into 4 times 10. Square root of 4 is 2, so you have 2 square root of 10 for the distance between those 2 points. Number 53, we're asked to find the midpoint between these 2 points. So we have point 1, which is x1, y1, and point 2, which we'll label with x2, y2. The midpoint formula is just the average of our 2 points. So you take the x values and you add them together and divide by 2. You take the y values, you add them together, and you divide by 2. Pretty easy. So we'll take negative 3 plus 5 divided by 2, and 4 plus 1 divided by 2. Negative 3 plus 5 is 2 over 2. 4 plus 1 is 5 over 2. And we're going to simplify that to 1 comma 2.5. You can leave it as 5 over 2, or you could write as 2 and 1/2 if you wanted to. Next, we're asked to write the equation of a line in slope-intercept form, which is y equals mx plus b, for the line passing through these 2 points, 1, negative 2, and 2, 0. So the first thing we need to do is find the slope. So the slope between these 2 points, you can do 0 minus a negative 2. That's the change in y. Just keep in mind that the slope formula is the change in y divided by the change in x. So I chose to go with 0 minus a negative 2 in the numerator, so I need to do 2 minus 1 in the denominator. 0 minus a negative 2 becomes 0 plus 2. 2 minus 1 is 1, so our slope for this line is just simply 2. Once you have the slope, plug it into your equation. Y equals 2x plus b. Now we need the y-intercept. So choose a point, and I'm going to choose 1, negative 2. We'll plug the negative 2 in for y, and we'll plug the 1 in for x. Okay, so now we have to solve for the y-intercept. So we have 2 equals 2 plus b. Just be careful, we're subtracting 2 from both sides. It's not going to go to 0, but it's going to make negative 4 on the left-hand side. This is 0 right here though, but then we have b. So b is equal to negative 4. Our slope was 2. Pull it all together and write your equation. Y equals 2x minus 4. Don't forget that you can check your work by plugging your points in and making sure that they work in the equation. Like if you plug 1 in for x, 2 times 1 is 2, minus 4, it'll give you the negative 2 for y. If you plug in 2 for x, 2 times 2 is 4, minus that 4 is 0. So both points work. So this has to be the equation for the line through those two specific points. So number 55, we're given that the midpoint of line segment AB is at the point negative or 1, negative 2. 1, negative 2. And A has coordinates negative 2, 0. And we're being asked to find the coordinates of the other endpoint at B. So one way to do it is by taking your points and plugging them into the midpoint formula. So I would take negative 2 plus x divided by 2 and 0 plus y divided by 2. We're going to set this equal to the actual midpoint of 1, negative 2. So that means that you can do negative 2 plus x over 2 and set it equal to 1. And you can do, let's just change this to y over 2 and set it equal to negative 2. So basically you're setting up two proportions to solve. So put this in parentheses, put this over 1, cross multiply. 2 times 1 is 2. 1 times negative 2 plus x will just give you negative 2 plus x. And then take and add 2 to both sides. 2 plus 2 is 4. That's equal to x. So this point has an x value of 4. For the y value, solve this equation. Again, it's a proportion, so cross multiply. 2 times negative 2 is negative 4. Y times 1 is just y. So y equals negative 4. That's it. There is a shorter method. Well, some people think it's shorter. If you take a look at your x value and you go from negative 2 to positive 1, to get that positive 1, you would have to add 3 to that x. If you take 1 plus 3, again, that'll give you the other x coordinate of the other endpoint, and 1 plus 3 is 4. For the y's, do the same thing. To go from 0 to negative 2, you're subtracting 2. So to go from negative 2 to the other endpoint, you have to subtract 2 again. Negative 2 minus 2, negative 4. Just another way to solve it. Okay, number 56, we're asked to graph the line through the point 1, 3, perpendicular to y equals negative 2x plus 4. The slope of this line is negative 2. The slope of our new line would have to be the negative reciprocal of this. So the slope of the new line is positive 1/2. And here's how I get that. If you take a slope of negative 2, right, as a fraction, the reciprocal of 2 over 1 would be 1 over 2. This slope is negative, meaning it's going to go in this direction when you graph it. So our line, in order to be perpendicular to it, has to have a positive slope. So lines that fall from left to right have a negative slope, and lines that rise from left to right have a positive slope. Okay, so we have to plot our point and then use our slope to find more points on the line. I think we can get away with putting the x and the y-axis right in the center. So this is the y-axis. This is the x-axis. You need to plot a starting point first. So we go to the right 1 and up 3 for point A. And a slope of 1/2 means that the change in y is positive 1 and the change in x is positive 2. So we want to go from this point up 1 and then to the right 2. Up 1 to the right 2. Or you could always do down 1 and to the left 2. Down 1, left 2. Down 1, left 2. And then take and connect all those points with a nice straight line. And that's it. In question number 57, we're asked to prove whether quadrilateral ABCD is a parallelogram. And the quickest way to do that is to use slope. By definition, a parallelogram is a quadrilateral where both pairs of opposite sides are parallel to each other. And the quickest way to prove that lines are parallel or not parallel is to use slope. Now, for some reason, my graph didn't transfer over, so I'm going to sketch it just on a little xy axis. So A is at 0, 0. B is at the point 2, 3. C is at 5, 1. And D is at 3, negative 2. So your graph is probably a lot better than mine. Okay, so we want to take a look at the slopes of opposite sides. So we want to take a look at the slope of AB and compare it to the slope of line segment CD. We want to look at the slope of BC. We want to compare it to the slope of line segment AD. So for line B, the slope, just a reminder, slope is the change in y divided by the change in x. So we'll have 3 minus 0 divided by 2 minus 0, or 3 over 2. The slope for CD, we'll do 1 minus a negative 2, which turns into 1 plus 2, which is 3. And then we're going to divide that by 5 minus 3, which is 2. Okay, same slope here, so that means that indeed AB is parallel to CD. So far we've got a trapezoid because we have at least one pair of parallel sides. Okay, continue by finding the slope for line segment BC. So let's do 3 minus 1 divided by 2 minus 5. 3 minus 1 is 2. 2 minus 5 is negative 3. Okay, and let's compare that to the slope of line segment AD. So it'd be 0 minus a negative 2 divided by 0 minus 3. That subtracting a negative turns into addition, so that's 2 over negative 3. Okay, check it out. These two have the same slope, so BC is parallel to AD. Okay, we can say for sure that yes, ABCD is a parallelogram because both pairs of opposite sides are parallel. Now it doesn't ask us this, but we could actually prove that it's a rectangle because if you notice, these slopes are negative reciprocals of each other, making those lines perpendicular to each other. Consecutive sides are perpendicular to each other. But we can stop by justifying that it's a parallelogram. That's all we were asked to prove. All right, good luck with the rest of your studying.